Welcome to EDU World Space.
Let's talk about obesity statistics. We're given a 95% confidence interval that says that the proportion of people who are obese is between 22.4% and 23.5%. Now this looks a little bit different than other problems, so the first step is to write this as, instead of p is between two values, p is equal to some estimate plus or minus some standard error. And how do we do this? Well, we got to take the average of these 2 percentage points. And if we do that, we can just plug that into a calculator. What we get is 22.95%, or 0.2295. What's our standard error then? It's how far away this is from either one of those. And again, we can just subtract that in a calculator to get 0.0055, which is just about half of a percentage point. So we have our estimate for p hat. What's q hat then? Q hat is going to be 1 minus 0.2295. And our last value that we need is our z-score. Since we're talking about a 95% confidence interval, this is going to be 1.996. Great. So now we can plug this into our formula. N is equal to p hat q hat times the z-score over the standard error, all squared. Again, p is 0.2295, q is 1 minus 0.2295, our z-score is 1.96, and our error is 0.0055. We're going to square that. Plugging this into a calculator, we get a pretty large number. What we get is 22,456, and that's pretty big. That's a large sample size. And why is that? Well, let's look back at what our estimate is. P looks pretty normal, so does Q, and Z is the same as usual, but let's look at the standard error. This is tiny. This is less than 0.5%, which is a really slim margin of error, especially for a 95% confidence interval. So because we've really shrunk down the possible error, we need a huge sample size to get this.